Mr. Beck, it is your turn, brother. It is your turn to turn and burn underneath the BBI magnifying glass of life. Here's your straight 4-pill, bro. And here's your BBI 2879 1-pill driver at number 1901 that you ordered as a pair. We went ahead and we went through all of this to give you some B+ upgrades. We went ahead and put bias in this thing for you and got it all set up for sideband. Because just having a switch on the front that says SSB does not necessarily mean that you're ready to rock and roll on sideband. You have to bias down the transistors, or otherwise you'll end up having burnt down pills. Well, we got this all tuned out. The input tune on it's perfect. Then we went ahead and we hooked him up with one of these. This is actually my personal box that I had built for myself here a couple weeks ago during the Christmas break, and had it sitting on the shelf, and well, the guy offered me the right amount of money for it, so bam, it's now his. He wanted a driver for his little 4-pill. But it's done, bro. All right, let's go around the band. We use a 1,000-watt slug and peak, 1,000-watt slug and average, 5-watt slug and reverse, back from the Bird 10,000-watt dummy load. We're going to use a Striker 955, and we're going to use a Bird 43 with the 5-watt slug and reverse between the 955, the 1-pill, and the 4-pill. So first, now you got to remember, John's using like a 25 or 30-watt radio. Okay, so we're going to run this all the way through with the Striker. And we're going to come back and hit it with a 66V. All right. This is going to swing 100 watts into this, or 80 watts into this, and we're going to get roughly 1,000 watts out of that with just that amount of drive. And we're going to go over here, we're going to hit this one all by itself, we're going to get about 200 watts of drive, then we're going to hit that into that, and we're going to get 1,000 watt plus. Ta-da! Okay. First things first, shut the amp off. Hello, audio at 80 watts. Input tune passing through the box. Hello. Beauty. Turn the amp on. 1 watt dead key, John, gets you nothing. Hello, audio. It's about 850 watts of peak power, right? Input tune. Hello, audio. Remember, it's going down, going through, coming through this connector, around into here, and then input tune. It is flat as a pancake, bro, which is what we want. We're going to fire up our little 1-pill. Hello, audio. It's about 200. Input tune. Hello, audio. And then together, grand slam, all 2 boxes. Hello, audio. Now that 1 watt dead key and the 1-pill modulator gets you about 110 watt dead carrier here. Hello. Swinging right over in the corner. All right. John, I'm going to switch radios to something that puts out power more like what you've got down there, and we'll continue on. So give me just a second. Okay, John, we've pulled on back here. We switched down to the 66V. Old Squeaky is what I like to call her. RF gets into this microphone at all. Ferrite choke, another ferrite choke. There's about 4 inside a radio. It just squeals. Anyhow, that radio does about a whole hello audio. Maybe a whole 12, 15 watts worth of power. So this will get you a little bit closer to what you're actually going to end up using in the long run, I do believe. So let's get on with this. We're going to fire down on the 1-pill. Hello, audio. Whole 110 watts worth of drive that you're going to get out of this, with about a 20 to 30 watt input. 20 to 30 watts into the 4-pill. Hello, audio. A whopping 400. We'll hit this with a 1-pill modulator. Hello in the corner. Hello in the corner. So that works. So you're getting about 400 bird out of this. Hello. And we're squealing. Old squeaky. Point is, 400, 425 bird, 1,000 watts out. On 14.5. You can't go wrong. Said you can't go wrong, Captain. Let's see how warm everything is here real quick. Oh yeah, you can tell I've been running around the bench. Oh, look at that. The pills are nice and cold. That's what we're after. These ceramic resistors, wire wound ceramic inserted for resistors. Now the wire winding on the inside is teeny, but the ceramic on the outside, does it help dissipate the heat, create more surface area? It's a heat sink for the resistor. Anyhow, what happens is this relay kicks on, feeds this 12 volts. There's a diode that's here, okay, and that emulates a load to ground, okay. There's a capacitor and a tantalum capacitor here to ripple out, to slow out the voltage drop and the ripple current. Because remember, you want to switch this on and off. You don't want that bias resistor to always be on. Because most of the time, the amp is in the off mode. It's only maybe every 10% of the time of the amp's actual life where it's on. Probably a number lower than that. So you don't want these resistors sitting there cooking all the time. So you turn the current for the bias off. Cut it down. Well, think about what sits right over that. Got a fan, okay? So these can get hotter than dickens, but they're air cooled. They've got a large amount of surface area, which allows the air to flow over it, and the molecules will strip away the heat and gets conducted out the box. So these cool off in a New York second. Same thing over here. This amp is mostly in standby. Now there's no fan to move air through this cabinet. We're just allowing the air space inside the box to take care of the problem. The amp is always in standby mode. Now, believe it or not, that's how that works. That's as hard as it is to bias a box. You cannot exceed more than 3.8 or 0.38 volts. Okay, so 380 millis worth of current on the input, or otherwise you'll cause the transistors to go pop, because it'll be too close of a 12 volt reference to its emitter source. Anyhow, that's how that works. You can't go wrong. She is cranking just the way you need her to. Mr. Beck, be good, my brother. I appreciate you sending this up. I appreciate your patience. Now I gotta go finish a 12 pill that I've been putting off all the weekend because I've been dinking off with my family. Hey, don't blame me. I want to spend time with my kids, not work on amps all the damn time. I mean, can I go wrong there either? No, I don't think it can. My name is BBI. Without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out, www.bbiamps.com, or come bump into me on the bowl. That's 27.025, by the way, channel 6. Or come find me on Facebook, come find me on Pal Talk, room's name's 27.025, or come find me on Snapchat, Instagram, or Twitter. And if I haven't bored you to death yet, click subscribe. And these magical things will happen. The box will go from gray to red, and then all of a sudden you get an email every time I put one of these silly videos up. I appreciate you folks. You all be good. I'm not here without all of you, and that's just the way it is. I'll see ya.